Hello viewers, in this podcast we are going to talk about Gen AI. What Gen AI means to the enterprises especially, what are the various components of Gen AI, the building blocks, and we are going to hear from the experts. We have Shaurya with us and we have Ravi.
Either partners or technology vendors about Gen AI, and a lot of partners and a lot of vendors are definitely talking to a lot of customers. Everybody wants to pitch their own solutions for Gen AI use cases.
People think of Gen AI as acquiring yet another software solution.
It's a good, yeah.
Right? So we have Kafka, we have Elasticsearch, we also have Gen AI for mobile. But Gen AI effectively is, or AI is a separate practice.
So let's get started.
This kind of challenges organizations have. So in that case, let's try to demystify
Yeah, correct,
or
absolutely.
deconstruct what are the various building blocks of Gen AI for the enterprises and how one should go about, or for the viewers, maybe let's talk about each component and give them some insights. What is LLM? What is RAG? What is hallucination, right?
Correct, yeah.
How do you train your, what do you mean by training your data and things like that. You have built these systems. you have been one of the few companies or early ones who have actually built the whole end-to-end thing and have seen the result, including hiring your NVIDIA GPUs, right?
Yeah.
And running your training model.
Yeah.
So in that context, where do you want to start with in explaining what are the building blocks and
Now to the
Yeah, so
Correct.
one thing that I've noticed, and I think it came out from your previous question as well, was what I'm noticing is people think of Gen AI as acquiring yet another software solution.
It's a good, yeah.
Right? So we have Kafka, we have Elasticsearch, we also have Gen AI for mobile. But Gen AI effectively is, or AI is a separate practice. So you're not acquiring a new software, you're effectively opening a new vertical in your company. If I'm looking at the very highest
It's a new
level.
mindset, basically. I think it's a practice.
It's a practice. It's a, from the ground up, it's a new practice that you're setting up. Which ultimately right now you're investing in the people, you're investing in the software, you're investing in the infrastructure of that vertical, with the expectation that 1 year, 2 year, 3 year down the line, it will start showing a profit graph. And that graph, all data indicates right now is that graph will be exponential as we go along. It will bring efficiencies in terms of, what is our dream? We want everything right now for free. Right? Ideally, even better, I should be paid for, you doing my work and you should pay me. Right? So this gets us closer to that goal. Because so many things that we were, just spinning our wheels on without any outcomes, those things go away. So in a typical enterprise, there's this idea called yak shaving. Do you know?
No.
So the yak shaving thing is, I can give you an analogy in like normal sense. Let's say I have to clean my room. For that, I need garbage bags. But I don't have garbage bags, I need to go to the store. To go to the store, I need my car. My car keys are lost in the room. Find the car keys, I have to clean the room. So many organizations have these spinny circles.
Yeah.
You have an approver. Before the approver, there has to be a checker. Before the checker, there has to be a maker. Before the maker, someone has to approve that this guy can make. The approver needs a change request. What? So this spinning around and around and around, you have a regular QA, then you have an end-to-end QA. Why didn't you do it in the one? No, we have a separate end-to-end QA. And then we have a full cycle QA. What's the difference between a full cycle and an end-to-end QA? Somebody gets paid extra. So all these things start getting eliminated because you have now a vertical that is focused on efficiency.
Because that's a very pertinent point. A lot of time we see that the enterprises were attempting to build something on GenAI. They're either trying to carve out some time from the team which are already doing a lot of other stuff,
Yeah.
or they are trying to either build something which is already being built up, and along with that just maybe add one more module.
It's a strategic investment.
Yes.
You have to think of it like that
Right.
instead of.
So, if they can start off, would you say you have to start with your data in mind? What data you want to really leverage? So, do you have to start with put all your data together, and which is never happened in the enterprise?
Yeah, no. So I think a big bang start with a lot of investment. Those days are gone.
Gone, right? Everybody wants to start small, show me results.
Start with like a $20 subscription to ChatGPT if you want to, or even for free.
Right.
But start with strategy in mind.
So
Instead
some
of
business outcomes. So focus
Yeah.
on some business outcomes.
focus on some outcomes, but don't hold yourself down to okay, we are going to cut costs by 10%, come hell or high water, because now we are subscribing to OpenAI. That is
Yeah.
problematic. But something very simple that I've seen happening, and this is LLMs are brilliant at it. You give them a process and say optimize it.
Mm-hmm.
They can actually cut short all the duplicates.
Well, we talked about LLM so many times. Can we go little inside it? And
Inside the LLM, yeah, why not?
People talk a lot about LLM, and so what is basically LLM? And there are too many words or terminologies associated with it. So, can you simplify them?
Yeah, so let's talk only what an LLM is, what a
Right.
large language model is. Okay, imagine you have a library, right?
Book library.
Book library. Either you are a big college or you are like a
City library.
city library, something.
Mhm.
Variety of books, variety of periodicals, one library. Now imagine that librarian is absolute genius.
Mm.
So that person has read all the books. Now imagine you going and talking to that person. So in your image, in your head, you have some Einstein looking person who's very rude to you and doesn't want to talk to you because you're an idiot. You've read only 3 books in your life and that person has read hundreds. So now imagine that librarian being very, very, very friendly with you. Knowing who you are, knowing about your family, knowing what your job you do, knowing what pressures you are under,
Mhm.
right? And then you go and ask that librarian, hey man, I'm trying to build a bridge and I don't know how to put these 2 classes together. And that person sits you down over a cup of coffee and explains. That's what an LLM is. They are now able to handle what was once a very difficult problem. I don't think that problem is solvable yet.
So
But,
one
they're not
related-
able to handle the framing problem.
Sorry, I mean, cut you off.
Yeah,
But
yeah.
related question. So you are talking about example, using your example that if that person knows me,
Yeah.
the moment I enter, he knows my background, my family, and that's why.
By that I mean
he's
the
a-
context.
So exactly. So based on that, if LLM knows about me so much, would it build bias?
No. The LLM doesn't know about you as a person. The LLM knows about the conversation we're having now. So back in the day, if you had to do a Google search, you would basically Google search parts of a bridge, how to make bridge stronger.
Right.
It will direct you to a forum, it will do something. Right now, you can actually have, I want to make a bridge, I want to make it stronger. What are the typical strategies? Alright, I like strategy number 2, can you explain more that? So it will remember you where the conversation started and it can. Earlier, even with Google, if you did 2 searches, the chances of those 2 searches getting related,
Very remote.
Minimal.
Very remote. Yes.
unless you decide to share all your data with Google and also sign a slavery agreement and whatever.
So this is
Yeah.
basically contextualizes.
Contextualizing.
And how does it happen internally? What are the various components inside?
So the first thing they did in the world was create a pre-trained model. So that's the generative pre-trained transformer, right? So the pre-trained
GPT
model.
model.
Yeah. So the pre-trained part was generalized pre-trained or generative pre-trained, I don't remember. But the pre-trained part was they took almost everything humans had written. Right? It's called the common.
Till 2021.
Huh?
Till 2021.
Till 2021. I forget the name of the data set. But they basically said, hey, let's start looking at this data set and see what correlations exist. Before that, we had this idea of creating a knowledge graph or identifying all the entities and saying dog, cat, pets are 3 words that are related somehow, right? But this thing was the first time we actually attempted to just correlate all the data that we knew.
And who attempted that with that correlation? So that was a algorithm built?
Yeah, multiple parties have done it. Humans did it basically, and because it was open source, people could collaborate across multiple organizations. So Google came up with BERT, and then OpenAI came up with GPT-1, GPT-2. Those were like really early versions of this thing, right? So GPT-3 or 3.5 is what really took off.
Yeah.
Right? But before that there was 1 and 2, right? So all that does is when you ask it a question, the first thing it will do is look at the pre-trained model and try to break your question into parts. I want to give me a question.
Build a bridge. Let's take a
Build
bridge.
a bridge. So it will now say what are the constituent parts, and I'm just giving an example, but I want to can be one part, build a can be one part, and bridge, just like we do in English, right? Subject, verb, object, right? So similarly, it will try to tokenize it. Now that tokenization is built on hundreds and thousands of ideas that the pre-trained model has ingested, right? So imagine for every token having 2 to the power, okay, we have length, breadth and height, 3 dimensions. We say length, breadth, height, time, 4 dimensions. If I have something in 5 dimensions, how complex is it?
Absolutely.
Right? What if I had 16,000 dimensions? Right? So 2 to the power 14. So every token is encoded in a number that is 2 to the power 14 dimensions.
Oh.
Right? And so it gives you like a giant directory of, hey, the word the can have these many different things.
2 to the power of 14.
Yeah.
The word yellow can have these many things. The word bridge can have these many things. So now we can tokenize things properly.
Oh.
And now we have a self-attention model which says which part of this statement should I pay attention to. The word A, the letter A, in I want to build a bridge, is probably not that important as the word B, bridge.
Yeah.
So now we have a model, because those huge pre-training, that can say pay attention to these parts. Based on these parts, go back to your corpus and tell me which are the most likely answers to this question. And then once you have the first answer, literally the first word typically is sure here, are a few ways.
Correct.
Sure. Then okay, if the first word is sure, what is the next most likely word?
Oh.
And so for every token it generates, it will keep going and parsing the entire corpus again and again and again and again and again. So that's basically all that is happening. We have a huge battery, right? And we just keep going. So it's like a librarian. A librarian took your request, looked at you kindly, understood where you're coming from,
Correct.
what parts to pay attention to.
Yes.
So if you went to a librarian and said, I want to build a bridge, and some librarian said, no, bridge is a game, get lost, you don't know anything. They didn't care about your context,
Correct.
right?
Yeah, they could find bridge as whatever.
A game or something else.
Somebody is looking for a toy. Bridge is a toy.
So the most important thing, context.
Context. So now we have a machine that can not only has read libraries worth of data, but also understands the context, because it has learned somehow to pay attention to the right parts.
So is LLM everything about Gen AI, or there are more things, right?
So right now, currently, things that we can actually pick up and use. There are lots of things that are on the edge that are upcoming, because the field has just started. 10 years later, we'll not be able to recognize what's what. But right now, the two things that are there is when you start with an LLM, any LLM, you take Llama 3, you take whatever, OpenAI's.
What does it take to run these LLMs in your premise or on your machine?
A lightweight one can actually run on your laptop.
I saw one of
Yeah.
those running on your laptop without internet.
Yeah. Also, a lightweight one can run on, but the more sophisticated you get, you definitely need some GPU investment.
Huge amount of compute power.
Not too huge, but at least one solid GPU is important.
One solid GPU today, getting a GPU is the biggest challenge today. Right?
Well, a laptop with a 4090 GPU is clocking at about 3.5 lakh rupees. So,
Which is
I mean, for data centers, of course, it's cheaper.
cheaper.
but,
Yeah. So one is running LLM, and there are many LLMs.
Yeah.
But does that give a complete power
I was
for the
coming
enterprises?
to that. So, think of LLM as a new dog or a new car. It's fresh mint out of the factory. Nothing has happened on it. Okay. Now, in a new car, they say please run it not too fast, but run it for a little while. So it will change according to your driving style. It will adapt to it, and you will adapt to it. So that part is called fine tuning. Or when you bring a new dog home, you have to train the dog.
Right.
That's called fine tuning. Right. So that is the first and the most effective thing we can do with an LLM. We can fine tune an LLM to listen to our instructions, follow our instructions better. If you are a law firm, you have to be able to answer a certain way. So here's a very interesting thing that I just learned about it. Right. So it's ingested all the knowledge. Right. There used to be a time when cocaine was administered as a painkiller.
Yeah.
Long time back,
Yes.
yeah.
Right? So it's in medical journals, legit medical journals
Correct.
say
Yes.
administer cocaine if there's pain.
Yes.
There used to be a time when this floor disinfectant, Dettol and Lysol, used to be put in eyes to disinfect the eyes before the cataract surgery. Not joking. Right? So there's legit medical literature that the LLM has read where it says Dettol can be put in eyes.
It's legal as well as safe.
Cocaine can be administered. But then there is new data that says don't do that, that's just dumb. Right? So you have to fine tune the LLM to ignore the past and preferentially answer scientific questions based on the latest research.
Obviously.
That's fine tuning.
So is that a science or an art? Is there a science in fine tuning this?
It's a math, it's science, it's art.
It's an art also.
So because
Skills, basically.
Yeah, it's a skill. You have
It's
to
a skill,
learn,
yeah.
right? It's a like I said, it's a practice. So when you are in an enterprise, answering questions that are very aligned to the culture of your enterprise,
Your business.
optimal to your business outcomes, aligned. So you're not just wasting somebody's time and giving weird answers. So you have to fine tune it. And the other part is just like if I was to come up with a scientific experiment and I said I did some experiment and what I can give me some example, but I can I can test your blood type with my cell phone, right? And I look at you, I click your picture and say you're A positive, I click your picture and say you're O positive. You'll say what's the proof? What is the proof that your science works?
Correct.
That's where we build a RAG. So a RAG, module, is nothing but is built to get the proof that whatever your LLM suggested, it based those suggestions on this.
On your data,
Purpose.
on your actual data.
Whatever data, whether you purchase that data, whether it's
Enterprise
data, it is based on, and that's essential for an enterprise because if you go into decision automation, you have to be able to backtrack for an audit or for any kind of compliance requirement. You have to be combative and say, why did you take that decision? Who asked you to reduce storage there? Who asked you to optimize this part? Well, this is the data that I based it on. So that's where you need that library, which is the RAG.
So, for example, you are saying if organization is putting up this GenAI based front end for their customer, let's say bank wants to create a conversational website and where customers can actually talk, which is to be a dream, which is to be a chatbot kind of a thing.
We've tried it many times, yeah.
But again, chatbot had limitations. Maybe we can talk about that. But in this case, you are saying that this conversation, LLM finds a context, understands what I am asking, and if somebody is saying I want, for example, fixed deposit, cumulative fixed deposit returns.
Right.
So has got a word cumulative, has got a word called fixed deposit. So it understands, and then it has to make sure that it is bringing data from its own repository. Because cumulative could be, context could be very different.
Yeah.
So how does that process work?
So that's, first of all, that's fine tuning fundamentally.
Okay.
That's fine tuning, and then slowly you have to teach the language model. So you're effectively teaching your vocabulary, your business
To the LLM.
So how can you represent knowledge? Let me just explain that part. So the way you represent knowledge is you first teach basic logic to any device. We've done this thousands of times, true, false, and, or, if, else, that logic. The second is you teach vocabulary ontologies. Ontology is basically a tree of all the concepts, right? So if I say dog is a mammal is a living creature, living creatures come from this thing. So you have an entire tree of concepts. So by the time I say dog, you kind of mentally picturized the tree. So that's the ontology, right? And then you create a network. Network basically means X plus Y has some meaning. Right, so in theorem proving, machine learning has a part called, or artificial intelligence has a part called theorem proving. You've seen these reports where LLMs say, oh, I can now solve a math Olympiad problem, right? That's theorem proving. Which says if P has some relationship with Q, so if we have P and that relationship, we can derive Q. Right? If man standing in rain gets wet, so the LLM can automatically say, oh, you were standing in rain, are you wet?
Okay.
Right? So it can then, outcome it can derive. So think about that complexity inside an enterprise. You have to teach the LLM how your organization works. You're getting it? That's fine tuning. So that part where you come to the network of knowledge, representing your knowledge into the LLM.
Right.
That bit is fine tuning. And then, well, where did you learn this? Oh, I have this entire corpus which I'll build a RAG so that it can retrieve the right documents based on it.
So is there, sorry, you complete it.
So man, no food is hungry. So if I like we were talking about this, I've not eaten anything in the anticipation of this recording. If I was an LLM, I'd say,
are you hungry?
Exactly.
Okay.
So that my customer who has a term insurance policy has not deposited the annual premium for 2 years now. What's the question? That's the statement. The question would be, is the policy still valid?
You're right.
Right?
Correct.
A general LLM doesn't know that. You will have to explain, hey, here are all the policies. So that's fine tuning basically.
So you have to basically feed all your terminology, your data, and make sure that
We find, and then so the LLM slowly learns to adapt. It doesn't happen overnight. You can't say, you know what, I'll get it done tomorrow 9 a.m. It's ready. It's going to slowly learn. It's a probabilistic. It learns.
It's an iterative process.
So that's why we call it a vertical. You can't expect it to be a software. I now have a new kind of a hard drive, so it's.
So you mentioned about this learn.
Yeah.
Where does that learning happen? And do you have you have to create some certain algorithms that learn from here, or is it a supervised one, or is it unsupervised one?
So it is partially supervised, partially unsupervised, but those words have little meaning now. So remember the pre-trained model that I told you about? Every token having 16,000 some 2 to the power 14 dimensions in it. So that's basically every dimension is basically a number, right? It's saying 0.33 here, 0.041 here, 0.045. So it's like a string of 16,000 plus numbers there. So the learning effectively is those numbers change just a little, just a little.
So as it finds more data coming in or more relevant data coming in, it's learning.
Tweaks those embeddings a little bit. So the same model, now the data that the numbers that are stored in that is slightly different.
Weightages keep changing. Okay, after this is the most relevant.
Yeah.
This is more relevant part.
So in a general LLM, if I have not eaten anything since morning, if the general LLM said, "Are you hungry?" Here the LLM say, "The cafeteria is now open. Can I order something?" Difference, slightly different. So cafeteria is slightly higher probability now than just asking generally, "Are you hungry?" That